Okay, so you're going to go ahead and you're going to get a problem like this on your test. So we're going to go ahead and we're just going to review how to do a standard algorithm in regards to subtraction. Okay, so our first step and one of the most important things when we set up a standard algorithm is making sure that all of our numbers are lined up. If they're not lined up, then we're going to run into some problems and we're not going to get the most accurate results. Okay, so our problem, go ahead, let's look at it, and it says 9,354 minus 3,637. All right, so I set it up nicely. It's all nice, lined up. My ones are where they have to be, my tens, my hundreds, and my thousands. So our first step when we're doing the standard algorithm is going from our ones and then our tens, hundreds, and thousands. So our first step is our ones. And it says 4 minus 7. And now let's think about that. Is that possible? Can we take away 7 from 4? No, we can't. It's not possible. So what we have to do is we have to look next door. So I really want you guys to remember our subtraction poem. If it's more on the top, there's no need to stop. If there's more on the floor, we have to go next door and get 10 more. So we need to borrow from the next place value. Okay, so let's look at this 5. We're going to go ahead and we're going to borrow from that number. Okay, so we're going to borrow from that. We're going to borrow 10. And so that 5 is now going to become a 4. And if we're borrowing 10, what's 10 plus 4? You should have said 14. So do you see how we borrowed 10 and we made that 4 now a 14? All right, so now let's look at what it's asking us. It's asking us 14 minus 7. Is that possible now? Yes, it is possible. So let's go ahead and let's subtract 14 minus 7. And what does that give you? You should have went ahead and you should have said 7. All right, so our ones place value is done. Now let's go ahead and let's look at our tens place value. It says 4 minus 3. Is that possible? Can you take away 3 from 4? Yes, you can. So 4 minus 3 is going to be what? You should have said 1. All right, now we have our ones done, we have our tens done. Now let's go ahead and let's look at the next place value, and that's going to be our hundreds. 3 minus 6. Well, let's think about that. Can we take away 6 from 3? You should have said no, it's not possible. So, what do we have to do? If it's not possible, we have to go ahead and we have to look next door. So let's look at our thousands place value. And we're going to go ahead and we're going to borrow from this 9. If we're borrowing from this 9, the 9 is going to become a what now? You should have said 8. The 9 is now going to become an 8. And if we're giving 10, this 3 is going to be what? 10 plus 3 is going to give you? You should have said 13. All right. Now let's go ahead and let's solve this. 13 minus 6. What is that? You should have said 7. 13 minus 6 is going to give you 7. All right, now our last place value is our thousands. 8 minus 3. Is that possible? Yes, it is. So what is 8 minus 3? You should have said 5. And here's our answer. It's going to be 5,717. All right, let's go ahead and let's look at another subtraction problem. And let's go ahead and let's look at what it says. You're going to have something like this similar to your test. So what is 700 less than 1,681? So our key word is going to be less. And when we see less, we know that that's going to be a subtraction problem. So 700 less than 1,681. Sorry. So let's go ahead, let's set it up like an algorithm. So we're going to put 100, or 1,000, I'm sorry, 681 minus 700. And remember, our number one rule when we go ahead and we do an algorithm is making sure that all of our numbers are lined up. So my ones are where they have to be, my tens, my hundreds, and my thousands are where we have to be. Remember what I said, that if there's no number underneath, let's just go ahead and let's add a 0 just so we can visually see. Okay? So let's go ahead and let's look at this. 1 minus 0. Easy enough, correct? 1 minus 0 is going to be 1. Awesome, we're done. Easy. Let's go to our tens. 8 minus 0. Another easy one. 8 minus 0 gives us 8. Now, let's go ahead and let's look at our hundreds. 6 minus 7. Well, can we take away 7 from 6? Is that possible? No, it's not. So what do we do? If you said we have to go next door, awesome. So we have to go ahead, we have to go next door, and we have to go ahead and we have to borrow. Well, if that's already a 1, if we're borrowing, taking away something from it, that's going to be a 0. And if we're giving 10 to this 6 is no longer a 6. 10 plus 6 now becomes 16. So let's look at the new thing. What does it say? 16 minus 7. What is your answer to that? If you said 9, you're correct. And there we go. 0 minus 0 is 0, so we don't need to go ahead and put a 0 right there. And we know that our answer is 981. Remember, you're going to have something like this similar to on the test. So make sure that when you see the word less, you automatically know that it's subtraction. Alright, so this problem right here says, what is the sum of 34,856 plus 4,565? And the most important thing is going to be the word sum, and we know that the sum means to add together. So let's go ahead and let's do a standard algorithm with this. So when I'm going to write out 34,856, my number one rule is to make sure that they are all lined up. If they're not lined up, then we're going to have a miscalculation. Alright, so they're all lined up, the numbers are where they have to be. So let's go ahead and let's start. Our first step is to solve our ones place value. And we have 6 plus 5. And 6 plus 5 is the same as saying what? You should have said 11. Now, can I put 11 in one place value? No, I cannot. So, if I write out the number 11, I'm looking for what place value right now? I'm looking for my ones. So I'm going to go ahead and I'm going to see which number in this is in the ones place, and that's going to be a 1. And now which number is in the tens place? That's also a 1. So I'm going to go ahead and I'm going to give it up here. I'm going to put it right there above the 5. Alright, I went ahead and I already solved my ones place value. Let's move on to our tens. I have 1 plus 5 plus 6. Alright, what is 1 plus 5? 1 plus 5 is 6, and 6 plus 6 is 12. Alright, remember, we're going to put the first number down, and then the second number is going to go to our next place value. So our first number is a 2, so I'm going to go ahead, I'm going to put it down, and my next number is a 1, I'm going to raise it up. Alright, so we're done with our tens. Let's move on to our hundreds. 1 plus 8 is the same as 9. 9 plus 5 is the same as what? You should have said 14. Alright, so I have 14. Remember, the first number goes on the bottom. The second number, you go ahead and you give it to the next place value. Alright, now I have 1 plus 4 plus 4. 1 plus 4 is the same as 5. 5 plus 4 is the same as 9. Alright, and remember what I said? If there is no number underneath, you can just go ahead and put a 0 to make it easier for you to see. Alright, and 3 plus 0 is the same as 3. Alright, I went ahead and solved it, and I have 39,421. All right, so let's go ahead and let's take a look at this word problem. This is going to be something similar that you're going to have on our test. So let's look at this sample question. And it says, Jacob has a binder that holds 700 Pokemon cards. He has already filled 256 slots with Pokemon cards. How many more slots does Jacob have left? And remember, our key word is going to be how many more. And when we see that key phrase, we're going to automatically know that it's subtraction. So I want you to think back to your study guide. They had 2 questions that had how many more, and remember how we solved it with subtraction. We're going to do the same thing with this one. So let's go ahead and I told you guys in class too that if we're having a hard time solving the algorithm, we can always go ahead and we can do an add-on. Sometimes though, an adding on is going to be a little bit more complicated than an algorithm, and sometimes our algorithm is going to be more complicated than adding on. So it's up to you to choose the best strategy that's going to work for you. So let's start off with solving this with an adding on solution, and then we'll go ahead and we will do an algorithm strategy. All right, so when we do an adding on strategy, we're going to go ahead and we're going to write the smallest number first, which is going to be 256, and we're going to go ahead, our end result is going to be 700. All right. So remember, our goal in to do an adding on is to have the fewest amount of jumps. So I'm starting off with 256. What is the next easy number? And remember, our easy number ends in 0. So what's the next easy number after this? You should say 260. All right, so our next easy number is going to be 260. And to get to 260, it's going to be how many jumps? You should have said 4. All right, so I'm at 260. What's my next easy number? Our next easy number, you should have said, is 300. And all right, to get from 260 to 300, how many jumps is that? You should have said 40. All right, friends, what's our next easy number? You should notice that the next easy thing to do is to get from 300 to 700. And how many jumps is it to 300 to 700? You should have said 400. All right, and our next step is to just add them all together. And if we do 400 plus 40, we know that is 440. And 440 plus 4 is going to give us 444. Pretty easy, right? All right, let's go ahead and let's solve this with an algorithm. So I'm going to go ahead and I'm going to put my 700 on the top, and I am going to subtract 256 from that. All right. So let's go ahead and let's look at this. 0 minus 6, is that possible? No, that's not going to be possible. So we're going to have to go ahead and we're going to have to look next door. But what do we see? What do we see next door? All right, so we see that that is a 0. And can we borrow anything from 0? No, we cannot borrow anything from 0. So we're going to have to go ahead and we're going to have to look again next door. And our next number is going to be in the hundreds place, which is going to be a 7. So we're going to go ahead and we're going to switch this 7 now to a 6 because we're going to go ahead and we're going to borrow. All right. And now can I go from 6 all the way to my ones place? No, that's not possible. I'm going to have to give it to my tens. So if I'm giving 10 to my tens place, this 0 is now going to become a 10. All right? But I can't do anything yet. I still have to give sum away to my ones place value. So this 10 now is going to become a 9, and this 0 is now going to become a 10 because I'm giving 10 to the 0. 10 plus 0 is 10. All right, now I can go ahead. I have everything set up. Now I can go ahead and I can subtract. I have 10 minus 6. Is that possible now? Yes, it is possible. So I'm going to go ahead and I'm going to subtract 6 from 10. So 10 minus 6 is the same as 4. All right, excellent. I solved my ones place value. Let's go ahead and let's solve our tens place value. And I have 9 minus 5. Is that possible? Yes, that is possible. And 9 minus 5 is the same as 4. Wonderful. All right, I went ahead and I solved my tens place value. Let's go ahead and let's solve our hundreds place value. And 6 minus 2 is the same as 4. Do 444 and 444 from this problem match up? Yes, they do. And I told you guys in class also that if you're not comfortable with the algorithm and you want to just double check your answer, you can also do adding on, and you can compare your answers to see if you have maybe made a mistake. That's an excellent way to double check your answers. So when we take our test and we are about to submit it, we can just go ahead and we can just look back at it and we can solve it again using a different strategy, to make sure that we have the correct answer. All right, so let's go ahead and let's look at this sample question. You're going to have something like this similar on the test. So let's go ahead and let's get started. A group of boys were collecting Pokemon cards. Each boy kept some of the collected Pokemon cards and sold the rest of the collected cards. The table below showed data for 3 boys in the group. Fill in the blanks below to complete the chart. All right, so let's go ahead and let's look at this. We know our boy A, our boy B, and our boy C. And what we do not know is the number kept. So that is what we don't know, and that is what we need to find out. We also know that the number sold. We know that boy A sold 45, we know that boy B sold 30, and we know that boy C sold 15. And we also are given the total number collected. We know that boy A collected 74, we know that boy B collected 85, and we know that boy C collected 39. So, in order to solve this, we can do it in 2 ways. We can go ahead and we could use algorithm, we can do add-on, but our main thing that we need to find out is the number kept. So we need to figure out what those numbers are. So a way we can do that is taking the total number collected and subtracting it from the total number sold is going to give us the total number kept. So let's go ahead and let's rewrite this so we can visually see it better. So our first one, boy A, let's go ahead and let's rewrite it to 74 minus 45. Let's go ahead and let's rewrite boy B, which is going to be 85 minus 30. And then let's go ahead and let's rewrite boy C, which is going to be 39 minus 15. All right, and so remember, there's 2 ways that we can solve subtraction. We can go ahead and we can do it in our algorithm. We can add on. So I'm going to go ahead and I'm going to do 2 algorithms for you, and then I'm going to do 1 adding on. So let's go ahead and let's do the first one as an adding on solution. So what we can do is, it's already nicely written out for us in our grid. So we can go ahead and we can do 45, and we're trying to get to what number? 74. All right. So let's go ahead and let's see. To get from 45, what is our next easy number after 45? You should have gone ahead and you should have said 50. So that's our next easy number. And from 45 to 50 is going to be 5 numbers or 5 jumps. So we're going to go ahead and put a 5. Then what could we do? From 50 to what? We're trying to get to 74. We go 50 to, let's go ahead and let's say 70. And 50 to 70 is going to give me 20. And our final jump, let's go from 70 to 74. And that is going to be 4 jumps. So let's go ahead and let's solve it. And 5 plus 20 is going to be the same as 25. And 25 plus 4 is going to give me 29. So I know that this number in here is going to be 29. All right, let's go ahead and let's solve the next two in our algorithm. So I'm going to go ahead and I'm going to do 85 minus 30. And I know that 5 minus 0 is going to be the same as 5. And I know that 8 minus 3 is going to be the same as 5. All set. Easy, just like that. So I know this missing number is going to be 55. Let's go ahead and let's do one more in an algorithm. I have 39 minus 15. So I'm going to go ahead, I'm going to write 39 minus 15. And 9 minus 5 is the same as saying 4. And 3 minus 1 is the same as saying 2. So I'm going to go ahead and I'm going to get 24. Alright, it's just as easy as that. Go ahead, you can either do your algorithm, you can go ahead and you can do your number line, whatever works best for you. Alright, so on your test, you're going to go ahead and you're going to get a problem that has to do with time. So we're going to go ahead and we're going to do a sample problem for us to practice that. So let's go ahead and let's read what the question says. It says, Sam has to read every day after school for 1 hour. He starts to read at 4:15. Part A. Sam reads his first book for 25 minutes. What time will he stop reading? Part B. How many more minutes does Sam have left to read another book? Alright, so this is going to be a 2-step, and we're going to have to go ahead and we're going to solve part A first, and then we'll be able to solve part B. The easiest way for us to do this is to go ahead and let's make ourselves a clock. Alright, so I have my first setup of a clock, and I'm going to go ahead and I'm going to fill it in. Alright, so I have my clock. Alright, and I know from one number to the next is going to be increased by 5. So let's go ahead, and he starts to read at 4:15. Alright, so let's go ahead and let's make our numbers. So he's going to go ahead and he's going to start at 4:15. Alright. And we know that he is going to start right here. Okay? And we know that the 15 is where the 3 is. Alright, let's go ahead and let's solve part A. Sam reads his first book for 25 minutes. What time will he stop reading? Alright, so we're going to have to go ahead and we're going to have to increase by 25 minutes. So let's go ahead and let's count. I know I'm starting at 4:15 and I'm stopping at 25 minutes. And I know that each jump is going to be 5. So we're going to have to go ahead and we're going to have to count by 5s. So I'm at 4:15, 4:20, which is 5, 4:25, 10, 4:30, 15, 4:35, 20, and 4:40, 25. So I went ahead and I stopped right here. So the answer to part A is going to be 4:40, because I know that the 8 represents a 40 on a clock. Alright, let's go ahead and let's solve part B. How many more minutes does Sam have left to read another book? Alright, so we know he gets 1 hour. Okay, so we know that he gets 1 hour every day to stop reading.
to have to read. So 1 hour from 4:15 is going to get me to 5:15, and we're going to go ahead and we have to stop again at the 3 because the 3 represents the 15 on the clock. So we're going to have to start from the 8 because that's where he finished his first book, and we have to go all the way to the hour, which is going to be at 5:15. So let's go ahead and let's count. All right, so I have 5 minutes, which gets me 4:45, 10 minutes, which gets me 4:50, 15 minutes, which gets me 4:55, 20 minutes, which gets me 5 o'clock, 25 minutes, which gets me 5:05, 30 minutes, which gets me 5:10, and 35 minutes, which gets me at 5:15 where I have to stop. So that is going to leave me 5, 10, 15, 20, 25, 30, 35. So my answer to part B is 35 minutes left to read another book. All right, so when we get a problem like this, just go ahead and make yourself a clock, and then remember that each time you go from one number to another, it's jumping by 5.